So here is a table, and we are going to start by finding derivatives using a table. So we're still dealing with all of our rules, but instead of looking at an equation, we're looking at a table. So let's say that h of x is f of x times g of x, and we want to find h prime of 5. So we deal with this the same way that we would deal with any other derivative. We find the derivative of f times g, which is by using the product rule. So we have, and we'll plug in a 5. The first, plugged in with a 5, times the derivative of the second, plus the second times the derivative of the first. Then we'll use our table, and we'll go figure out what all those things are. F of 5 is 0. G prime of 5 is 7. G of 5 is 3. F prime of 5 is 2. And I work it out, and I get 6. Alright, let's say that we want to find f of x divided by g of x, and we want to find h prime of 2. Alright, f of x divided by g of x, that's the quotient rule. So bottom, we'll go ahead and plug in the 2, times the derivative of the top, minus the top, times the derivative of the bottom, over the bottom squared. G of 2 is 5. F prime of 2 is negative 1. F of 2 is 1. G prime of 2 is 3. And then on the bottom it's G of 2 squared. So I'm going to go to G of 2, which is 5, and I square it. So I'm going to get 5 times negative 1, which is negative 5. Negative 5 minus 3 is negative 8. 5 squared is 25, so there's my answer. So this is not really any different from any of the other kinds of derivatives. It's just that you have to think about using the table rather than an equation. Alright, let's say that we have f of g of x. This is what h equals. And we want to find h prime of 2. Alright, so we're trying to figure out, this is the chain rule because g of x is like a function inside of f. So we're basically using the chain rule, and what the chain rule says is that you take the derivative of f and you leave g in there, then you multiply by the derivative of g. So basically this is saying f prime of g of 2 times g prime of 2. So we start with finding out what g of 2 is. G of 2 is 5. So then I have f prime of 5 times g prime of 2. So f prime of 5 is 2. G prime of 2 is 3. 2 times 3 is 6. Okay, we're going to do another one like that. Let's say that we have g of f of x, and we want to figure out h prime of 1. So the derivative is g prime of f of f. Well, I'm going to go ahead and put in the 1. So you start with what's out here, you take the derivative of it, leave f, then you multiply by the derivative of f at that time. So I'm going to figure out what f of 1 is. And then I multiply g prime of negative 1, which doesn't exist from this table, and then I don't have to do anything else in the problem. I'm going to do one more that does exist. So let's say I wanted to find the derivative at h prime of 1. So we would take the derivative of f, leave g, then take the derivative of the inside, which is g. So g of 1 is 2. F of 2 is, f prime of 2 is negative 1. G prime of 1 is 3. And I get negative 3. Alright, so h of x could be written lots of ways. Let's say I had 2 f of x plus 3 g of x minus 5, and I wanted to find h prime of 1. You would do it exactly the way you think you would. You would do 2, find the derivative at 1, plus 3, find the derivative at 1 of g, and then we're taking the derivative here, so the derivative of 5 would be 0, that wouldn't be on the end. So then I do 2 times f prime of 1, which is 0, 3 times g prime of 1, which is 3, 0 plus 3 times 3 is 9. Alright, let's say that I have this, and I want to find h prime of 2. Well, the derivative of the square root of g would be 1/2 times g of x to the negative 1/2, because I've rewritten this to the 1/2 power. But then after I do that, I have to find the derivative of g. So I multiply by the derivative of g. And technically, I'm plugging in a 2 because I'm finding it at g of 2 and g prime of 2. So then I will have 1/2. G of 2 is 5. 5 to the negative 1/2 is 1 over the square root of 5. So I'm going to go ahead and write that. G prime of 2 is 3. And so you can leave it like that, or you can write 3 over 2 square root of 5. Alright, one more problem that I want to deal with is an inverse kind of problem. And the inverses are really tricky. And so first I want to tell you the rule. If you have f inverse, h of x is f inverse prime of x. The rule to find the derivative is 1 over f prime of, I'm going to go ahead and call it x, and what happens here is this really isn't x. Even if it says x, it is not x, it is always y. Because it is the inverse, whatever is in this parentheses always, always, always is y. And then what's in the parentheses over here is the x value corresponding with that y. So let's say that I had h of x equals f inverse prime of x, and I want to find h prime of 1. And actually I wrote this wrong. It should say f inverse of x, and this is the derivative of h. So I'm sorry I wrote that wrong, but that's how you find it. So if I'm trying to find the derivative here, the rule is to do 1 over f prime of what this is y. 1 is y. So I'm looking for the x value that corresponds with y. So I'm going up here to the table and I'm looking at the y values of f. And here's 1. The x value corresponding is 2. So 2 is going in the parentheses. And then I do f prime of 2, which is negative 1. So negative 1 is the answer. We're going to do several more of those just to make sure you understand it. Alright, we have h of x equals g inverse of x, and we want to find the derivative at 2. So the derivative at 2 would be 1 over g prime of whatever value corresponds with 2. Remember that 2 is y, and we're looking for the x that corresponds with it. So I go to 2 on g. Here's 2. 2 goes in the parentheses. I figure out g prime of 2, which is 3, and 1/3 is the answer. Let's say that I have h of x is f inverse of x again, and I want to find h prime of 0. H prime of 0 equals 1 over f prime. That's why I'm looking for x again. So I go to f. I'm looking for 0. The x value is 5. And then I go to f prime of 5, which is 2, so it's 1/2. One last one. H of x is g inverse of x, and I want to find h prime of 5. That would be 1 over g prime of whatever x value corresponds with 5, which is 2. 1 over g prime of 2 would be 3. I will tell you that sometimes the problem might not have an h in it. It might just say find g inverse prime of 5. And if it does, you still do it the same way. 1 over g prime of the x value corresponding. This is the same problem as the last problem. I just wanted to show you it could be written differently. One last one. I also could write the f prime of g of x is a different way, like find f prime of g of 2. I would write it like that, and it might just tell you to find the derivative without having the h there, so we know that it's f prime of g of 2 times g prime of 2. You just never know how it might be written, and so again you go to g of 2, so that's 5, f prime of 5 is 2, g prime of 2 is 3, and so you get 6. So it might not have the h written, it might just have it written a different way. Okay, here's your try problems. H of x equals 3f of x, find h prime of 5. H of x equals g f of x, find h prime of 2. And h of x equals 1 over g of x, find h prime of 1.